Greetings, programs. Here we are again in the exciting world of statistics. This video is going to show you how to do the differences between means problem set. You already watched the lesson, I hope. So let's get right to it. I'm going to click that and then click the button to open it, however we do that. Bingo. So you can see that I have differences between means problems and also more probability problems and more central tendency and dispersion problems. Okay. I'm only interested as far as grading for this this assignment, the 3 problems on differences between means, but you know, hey, if you want to practice and get really, really good for the midterm, here's some more things that you really love. And here's some more of those things that, oh my God, do you love more than anything in the whole wide world? Okay, so I did the first problem of the differences between means. Okay, so here's the text of the problem. Compute the t-value and test the null hypothesis that there is no difference in driving ability before and after alcohol consumption to the 0.08 blood alcohol level. Use the 0.05 significance level in the table in Cougar courses. That means the appendix. And then in parentheses, I say that this is a two-tailed test. Okay? So, when you get, excuse me, a problem, you're going to have just 2 columns of numbers. Remember that. You know, in this one, it's Republicans and Democrats. You know, Republicans will be column X, Democrats will be column Y. So in this first problem, I have a column for before drinking and a column for after drinking and certain values for them. So what I've done is I put X next to before drinking, and then in the column immediately to the right, I have X squared, and then Y is after drinking, and then the column to the right of that is Y squared. So remember, the very first thing that you have to do is square each of these values and put those numbers over here. Okay, so you can see that I did that. These are real easy numbers. 2 times 2 is 4, 4 times 4 is 16, 1 times 1 is 1, and 0 times anything is 0. Same thing with the Y column, right? 2 times 2 is 4, 5 times 5 is 25, 3 times 3 is 9, all the way down. And after I have squared each number and put them in the appropriate columns, then I have to add up all of these columns. Okay, so the first column total is 13, the next 31, the next 29, and the next 97. And you can see by just counting the numbers that there are 10 values here in both columns. You know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the very first thing I'm going to put over here in my list of numbers that I'm calculating is the n. And for both of these columns, the n is equal to 10. So I'm just going to put it once. And then I have, you know, in the sum of the x values, which as we saw over here was 13. And then the sum of the value squared of x, which is 31. The sum of the y values, you know, the original y column, 29. And then the sum of the y values squared, which is 97. Then the next step is to get the mean for both of these groups. So the mean of x, remember the reason why you're keeping all these numbers handy is because you're going to use them as you go down through what you need to solve. The mean of x is just the sum of the original x column, which is 13, divided by the n, which is 10. So that equals 1.3. And then, just to make things easy for myself, I'm squaring 1.3 and putting the value for the mean x squared, which is 1.69. Then the mean of y, all I do is take the sum of the y column, the original y column, 29, divide it by 10, and I get 2.9. And if I squared that, or multiply 2.9 times 2.9, then I get this, 8.41. Then remember the next step is you have to calculate the variance of both of these columns. And remember when we went through the lesson, and you can certainly go back and watch that video again, that the formula for the variance is almost exactly the same as the formula for standard deviation that we used a couple lessons ago. You can also go back and watch that video if you want to see how that's done. But basically, in order to get the variance of x, you need the sum of the values squared of x divided by the n. So it's 31 divided by 10, which is 3.1. And then you subtract the mean squared of x from 3.1. So 3.1 minus 1.69 is 1.41. Let's just see if that really works here. 3.1 minus 1.69 equals, hey, how about that? 1.41, and there it is right there. Okay, so to get the variance of y, the y column, we're going to do the same thing. Remember the formula. You need the sum of the squared values of y, which is 97, and we're going to divide that by n, which is 10, and get 9.7, and then we're going to subtract the mean squared for the y column, 8.41, and we should get 1.29. So let's try that. 9.7 minus 8.41. Oh my God, it's so nice when it works, isn't it? 1.29, and that's what I have right here. Okay? Then after that, you have to do that horrible section of the problem where you have to find the standard error. And I did put that over here. Okay? Remember the standard error formula. Looks huge, but remember that it's just a whole bunch of n's. And the n in this problem is 10. So here's the formula. It has all of the n's and then just the variance for x and the variance for y. So we're just going to replace all of these symbols with values. So wherever n appears, we're going to put a 10. And then for these two variance values, we're going to put what we found. The variance of x is 1.41. The variance of y is 1.29. And then all we have to do is just do the math, okay? So 10 times 1.41 is 14.1. 10 times 1.29 is 12.9. And n plus n minus 2, or 10 plus 10 minus 2, is 20 minus 2 is 18. And then for this part, it's 10 plus 10, which is 20, and 10 times 10, which is 100. Okay? So we add these two numbers and get 27 divided by 18. And then we just carry this down as it is. 20 divided by 100. This comes out to 1.5, and this comes out to 0.2. And if we multiply those two together, we get 0.3. Let's see exactly what we get, right? 1.5 times 0.2. And yeah, we get exactly 0.3. So that's nice. We don't get all those billions of other numbers. Okay, so that's how we calculate standard error. And we have that here. Next, we need to find the calculated t-value. Remember how we do that? We have a simple fraction with both the means, the mean of x minus the mean of y, and that's divided by the standard error. So the original mean, remember that. The mean of x is 1.3, the mean of y is 2.9. So let's do that. 1.3 minus 2.9 equals, a negative 1.6. And then we're going to divide that by the standard error. And remember, you can always go back to the video for the lesson and watch all this, okay? So I'm going to divide negative 1.6 by 0.3. And what I come up with is negative 5.3 and a whole bunch of other 3's. So I'm just going to round that up to negative 5.3, which I have right here for the calculated t. Okay? Now, if you go into the appendix and look for the critical t-value. Now remember, this was a two-tailed test. Remember that? So we need to look in this row of alpha values and find 0.05 there. And then we're going to go down until we find 18. Okay, remember the formula for degrees of freedom is n plus, the n of x plus n of y minus 2. And both n's are equal to 10. So 10 plus 10 is 20, minus 2 is 18. So we need to go down the degree of freedom column to 18, and then straight across until we get over to this number, which is in the 0.05 column for a two-tailed test, 2.101. And lo and behold, oh my God, there it is. So we've calculated negative 5.3. Our critical T is 2.101. Our degrees of freedom is 18. And we have to decide, are we going to accept the null hypothesis or reject it? And the answer is we're going to reject it. And that may strike you as funny because remember what I said. The rule for accepting or rejecting is that if the calculated t is greater than the critical t, then you reject. But look, isn't a negative 5.3 less than a positive 2.101? And the answer is yes. So, immediately you would think that you would accept the null hypothesis because this number is less than this number. But the trick here is that this is a two-tailed test, and you have to imagine this curve with both tails. And the negative 5.3 that you calculated exists on below the mean down here, but there's also in a two-tailed test another tail with a positive 5.3 above the mean. And since this critical T is above the mean, you know, right about here, hypothetically, the positive 5.3, the other side of the two-tailed test, is on the same side of the mean, so you have to use that to make your decision. Okay, confusing? Yeah. I don't think I make it this confusing on the midterm. At any rate, the answer to this final question, accept or reject, is that you reject the null hypothesis. Now, here's the last thing I'm going to tell you. If this was a one-tailed test, then this is the only answer that you would see on this curve, because it would only be relating to one of the tails, and what you calculated is that negative 5.3. So if this was a one-tailed test, the answer would be to accept the null hypothesis. But since it's a two-tailed test and there exists areas with 5.3 on both sides of the mean, and the critical T exists on the right, as does positive 5.3, that's why you're going to reject the null hypothesis. Okay? Totally confused? Awesome. That means I'm doing my job. We can certainly go over this if you email me or come into the office hour. I want to show you the second problem just to show you this. The Republicans have one more value than the Democrats. So when you work this problem, the very first thing that you're going to put over here is that, you know, the N for Republicans equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 11. So the N for Republicans is 11, and the N for Democrats is 10. That makes a big difference when you're working through the problem, okay? So that's it. That's what I want to show you today, and good luck with this stuff. Remember, it looks intimidating, but this is nothing more than basic arithmetic. All you have to do is work your way through the problem, you know, slowly and step by step. Like the great man said, Jaime Escalante, step by step. Okay? So I hope you had as much fun as I did, and you got as much out of it as I did. And you know what I did this morning? I went and walked a German Shepherd. And what a great way to start my day. Okay? All right. I'll see you soon in another video, and have fun.